In this video, I'm going to talk about how to recognize relationships in your data when you're looking at a graph. So a relationship in a graph is when your graph is showing two variables that correlate with each other. And correlate means that two things go with or happen together, which means that when you have a correlation, the two variables are related to each other and they affect one another, so that when one of them changes, the other will change as well. So let's talk a little bit about some of the relationships you might see. The first is a direct relationship, and it means that when one variable increases, the other variable increases as well. So if I'm looking at this graph, as I go from left to right, I am increasing on the x-axis, and as I go up the side of the graph, I'm increasing in the y-axis. So if I follow this line that defines my graph here, as I'm going from left to right, I'm also going up. So that means that I have a direct relationship. And this is also the definition of a positive slope, just that I go up the graph as I'm going from left to right. And another word for direct relationship is just a positive correlation. An inverse relationship is when, as one variable increases, the other decreases. So it's the exact opposite of a direct relationship. So if I'm looking at this graph, as I go along the graph and move from left to right, I'm actually going down on the y-axis. So that means that I have a negative slope whenever you go down as you move from left to right. So this is what an inverse relationship looks like, and another way to refer to it is as a negative correlation. So now let's talk about another type of relationship, a linear relationship. And the definition of this one is that your data just forms a straight line or something very close to it, which is why it's called linear, which has the word line in it. So you may notice that all these points don't exactly form a straight line. Like if I were to literally go from one point to the next, it wouldn't really look like a straight line. It would have this zigzag pattern. But you're just looking for a general linear trend, so that overall the whole bunch of data that you have just looks like it's making a straight line as it goes from left to right. An exponential relationship, on the other hand, means that as one variable changes, the other changes exponentially, which means that the slope isn't constant, so it keeps changing, and then you end up with this curved line here. So an exponential relationship will always kind of look like a curved line overall, where a linear relationship generally looks like a straight line. So in both of these graphs, the linear and exponential that I just showed you, you might notice that they are also direct relationships, which means that they go up as you go from left to right. So both this exponential graph and all the linear graphs that I showed you go up as you're going from left to right, which means that they are both, in this case, linear and direct relationships, and then here exponential and direct relationships. But it doesn't have to be like that. You can have a linear relationship that is inverse, so that it goes down as you go from left to right. And you can also have an exponential graph that is inverse, so it also goes down as you go from left to right. So for linear and exponential, they can both be either direct or inverse relationships as well. So now let's talk about a different type of relationship, no relationship. So sometimes you might take your data and realize that there isn't a correlation between the variables. There just isn't a relationship there. They don't affect each other. And one way that this can look is just to have a scattered clump of data where there's no recognizable pattern. It's not going up, going down, there's no line that's either straight or curved. It's just this mass of data. And this just means that you don't have a relationship and the two variables don't affect or change each other. Another no relationship graph can be a horizontal straight line. So if your data is just flat, that also means there's no relationship. So it's another type of graph that tells you that you don't have a relationship in your data. And the reason is that if you look at what this graph is showing, it's showing that as the distance increases, the velocity stays the same. It stays at around between 4 and 4.5 meters per second. So that means that changing the distance has no effect on the velocity because it's just keeping it at the same value. So in general, this just means that There's no correlation or no pattern whenever you have a no relationship graph. So I hope that this was helpful and give you a little introduction to how to identify patterns and relationships in your own graphs.